Every downhill ski binding has a toe piece and a heel piece. In case of a fall, the toe usually releases sideways and the heel upwards or in multiple directions. The earliest bindings had no safety release or released only from one end, and they were made of stamped heavy steel. Today's bindings are made of lightweight materials such as extruded aluminium and fiberglass reinforced plastic. The binding is designed using 3D computer software, along with the molds and dies used to manufacture all its components. A prototype of each component is produced, and three-dimensional measuring tools are used to verify the specifications. The visible aluminium and plastic components are painted. They're cured in an oven for 40 minutes, and then at room temperature for another 24 hours. Companies typically produce high-end racing models, as well as less expensive ones for beginner to intermediate level skiers. This aluminium housing is for the toe piece of a racing binding. Plastic tabs which prevent the metal from marring the plastic ski boot are screwed on. Next comes the indicator for adjusting the release setting. The release setting determines how much torque, generated by the weight of the skier falling, will trigger the binding to release the boot. A bronze and aluminium ball joint is placed in a metal base. The ball joint, which this machine locks into place with a washer, acts as the rotational center of the toe piece when it releases. The ball joint is lubricated with grease. Then the base is put in an assembly fixture. The toe piece housing is added. As is a plastic cap with a white line on the side. The cap is screwed down, which compresses the spring underneath. As the cap lowers, its white line moves down the center of the release setting indicator to the maximum setting. The finished toe piece is tested. This machine stamps the company logo on the heel piece of a binding designed for a beginner to intermediate skier. Unlike an aluminium racing binding, this one is made of fiberglass reinforced plastic. It has a clear polyurethane protective cover that you press with a ski pole to release the binding to get in and out of the ski. Next, this piece is mounted to a base and the internal mechanism is assembled. This includes a screw-down cap that compresses a spring to varying degrees to produce a specific release setting. An automated machine tests each heel and toe piece to check if the mechanism functions correctly. Then another machine unscrews the cap halfway to lower the release setting to the midpoint. Now assembly resumes. A metal pin connects the pivoting top of the heel piece to the base. This setting tool locks the pin in its lateral position. Next, in a series of steps, the ski brake is mounted to the heel piece. The ski boot maintains pressure on the brake, keeping it in the off position. When the binding releases the boot in a fall, the removal of that pressure triggers the brake. Additional internal components are inserted, including a notching pin that locks the heel piece to the mounting plate of the ski after the binding has been adjusted to the length of the ski boot. These plastic caps hide the heads of the lateral metal pin. Finally, this lever is connected to the notching pin. You simply pull it up and back to disengage the pin and adjust the boot for length. The company subjects random samples from the production line to rigorous quality control tests. Bindings are made to international standards, which dictate how they're supposed to react to different types of falls at specific speeds, torques, and release settings. Provided the binding is correctly set, these standards ensure that it releases the ski boot to prevent injury, but otherwise they hold tight to get you over the hump. So there you have ski bindings. They might sound a bit complicated, but if you didn't have them, well, that would be a real bind.